All right, grab your spiral notebook, and what we're going to do is we're going to pick up from yesterday, and we're going to look at the third example of solving polynomials by factoring, okay? So the first thing I want to do is I want to do a quick little review factoring problem with you, all right? And what we're going to do is we are going to factor x cubed minus 27. All right, if you feel like you remember how to do this, then maybe this is a good opportunity to hit pause, factor it yourself, fast forward, see if you got it right, scooch on over to example 3. But there was a good number of you guys that were having a little bit of trouble remembering the formula, so it doesn't hurt to go over this one more time. So these types of problems, they're called the difference or sum of two perfect cubes, which is what we have right here. They're going to factor into this binomial and into a trinomial. And ultimately, it's a formula that's on the yellow factoring sheet or in your notes, okay? The first parenthesis, this first binomial, is the two roots of the term. So the root of x cubed is x, the cube root of 27 is 3, and you put the same sign in between them, okay? Now in this trinomial, how it's gonna work is we're gonna take this first root and we're gonna square it, and then what we do is we in the middle, we multiply the two roots, and that's where the 3x comes from. And then the last term is going to come from taking the last root, the 3, and we square it. So it's really pretty easy. It's just a matter of memorizing the formula. So then how the signs go, if you recall, it goes same sign as the original, which is right here. So this is going to go same sign. This sign is always the opposite sign, and this last is always positive, which is that acronym SOAP, which is sometimes what I say to students when they forget this factoring. I'm like, remember, it's that SOAP factoring, and that usually kind of jogs their memory and they can remember this formula. All right, now let's get to example 3. Let's go back over the steps for how we solve something like 2x to the fourth equals negative 16x, okay? So remember, your entry point for these are always the same, all right? No matter what the problem looks like, nobody should come to class and say, I didn't know what to do first. You always start by putting the equation in standard form, okay? The intention here is to set equal to 0. You do not need to write these steps again, but I think it's important that we reiterate them. This is going to be 2x to the fourth. I'm going to add over 16x, and now we have the equation in standard form. The next step we always look to do, no matter what, is look for a GCF. Sometimes there is, sometimes there's not, but you look for it. And if there is, we factor it out. What I'm seeing here is there's a greatest common factor of 2x. And when I factor that out, the result is going to be x cubed, and 16 divided by 2 is going to leave with 8. Okay? This next step for step 3, now this is where we need to refer to our notes or that yellow factoring flowchart, okay? This is where you factor completely. You have to look at the result right here that's left over and determine what type of factoring needs to be used to factor it down to either an x or an x squared so that we can solve it, okay? But x cubed definitely needs to be factored more. So what I recognize is, again, we see the sum of two cubes, which is what I just went over in the review problem. So the first binomial is the two roots with the same sign, okay? The cube root of 8 is 2. Now let's review this trinomial, right? We take the first term and you square it. You multiply the two roots in the middle and get 2x, and then you square the last root, 2, which is going to put a 4 here. And recall that the signs, okay, go same sign, opposite, always positive. So now what we're doing is we need to set each factor equal to 0, and we solve. Okay, so here's the factors we have. We have 2x equals 0, x plus 2 equals 0, and I've got this trinomial, which I probably should have mentioned before, but this trinomial is not going to factor more. You are not going to be able to split the last term, and it's not going to work out. So we've got this trinomial right here that does not factor more. So the first solution is going to be easy. This first one, when I divide both sides by 2, is going to result in x equals 0. Let's kind of box that up. We're done there. This one's going to be easy. We're going to minus 2 from both sides, and you get x equals negative 2. Well, this one's not quite so easy, okay, because it doesn't factor more. I can't use square roots because we have a middle b term. So what we're going to need to do here is we're going to need to use the quadratic formula. That's how we solve a quadratic that can't be factored. Probably a good time to put in your notes what the quadratic formula is. Recall, it's opposite of b, the middle term, plus or minus the square root of b squared minus 4 times a, the leading coefficient, okay, and c, which is the constant value, and we divide all of this by 2 times a, the leading coefficient, okay? So write this down in your spiral notebook, and what I want to do is we're going to solve x squared minus 2x plus 4 in the quadratic formula. So the a value of this is 1. The b value of this, here's where I'm looking, just in case you're not following. I'm looking right here, okay? This is what I'm solving. And so the a value, like I said, is 1. The b value is -2, and the c value is 4. If you feel comfortable with using the quadratic formula, again, maybe this is a good time to pause it, try it on your own, see if you get the right answer. All right, so first thing I want you to do when you use quadratic is I just want you to plug everything in. So opposite of b is going to be +2 plus or minus. I don't want you to plug in, so you have to plug in b squared. I do not want you writing -2 squared. You're going to end up putting that into your calculator incorrectly. Just do -2 squared in your head and put 4, okay? It's b squared is 4 minus 4 times the a value times the c value 4, and we divide all of that by 2 times the a. So your first step when you do the quadratic formula is just plug everything in, make sure that you're careful. The next step we're going to do is we're going to calculate the part underneath the radical. So I get 2 plus or minus the square root, and it's over 2. So it's a huge simplifying that happens between the first and second steps, okay? Pull out your calculator, go 4 minus 4 times 1 times 4, and what you're going to come up with is -12, which tells me that we've got a negative under the radical, so that tells me that we're going to end up having imaginary solutions. We got to simplify the square root of 12, okay? The square root of 12 is going to simplify, I'm going to do this off to the side here. The square root of -12 is going to break into the square root of -4 times the square root of 3. Square root of -4 is going to be 2i, and we're left with the square root of 3 left over. So let's come down here. Before we divide the 2's, I know it's very tempting right now to simplify the 2's, but you can't. Simplify that radical into 2i square root of 3 over 2. Then what we can do is we can take this 2 divided by 2, and we can take this 2 divided by 2. And it kind of looks like a heart, because what we're doing is we're giving both of those terms love, we're dividing both of them by 2. 2 divided by 2 is 1, plus or minus, and then we're going to be left with an I square root of 3. So those are 2 of the roots, and they are imaginary. Don't forget the other root was 0 from up here, and the other root was -2. And together, that makes a total of 4 roots, okay? Now, there's other problems in the homework that are going to work very similar to example 3. Just looking at a couple, I'm just kind of thinking ahead. Number 9 is going to work very similar to this. Maybe something like number 12 will work similar, okay? And there might even be another one, but I'm going to see if you can find it. So use this as an example when you see any of these with an x cubed. Now, the last thing that I was going to do is, this is optional here, okay? You can even pause the video and come back to it when you're ready. But what I would recommend is I want you to go ahead and start the homework, particularly make it your goal today to do the front side of the homework. If you have trouble with any of the problems, what I'm going to work through is I'm going to work through number 2, I'm going to work through numbers 4, and I'm going to work through numbers 5. I would prefer you, like I said, pause this video, go do your homework, do the best you can with it. If then you're finding you're having a couple problems with if you're having some confusion about some of the problems in the beginning, then just remember that you can come back to this video, you can watch me work out 2, 4, and 5, get a little boost of confidence, a little extra help, and see if you can then be independent on the rest of the homework, okay? All right, so if you're rejoining this video now to watch how to do number 2, let's go ahead and work through this problem. 4z to the 5th equals 84z to the 3rd. First thing, like always, write the equation in standard form. Okay, so when I factor out a 4z to the 3rd, the result is going to be 2z's left over, z squared, minus 84 divided by 4, which is 21. So the reason I picked this problem is I wanted to help you with what do you do if you look at this and we cannot factor the result more, okay? Because 21 is not a perfect square, so I can't do that squares will factor in with the plus minus. Well, it's no big deal. We set each factor equal to 0, okay, because we know how to solve a quadratic. That's what our last unit was about. All right, so let's go through this. We have z to the 3rd equals 0. Now let's review what this meant. This meant z times z times z is equal to 0. Okay, that means that the first z equals 0, the second z equals 0, and the third z equals 0. That means that there are 3 z's that equal 0. So recall what we say is z equals 0 with a multiplicity of 3. That's going to have a visual impact on the graph, but it's also going to count for 3 of the 5 solutions that we're going to solve. Okay, now let's solve this one over here. I'm going to add the 21 to both sides, and we get z squared equals 21. Because we don't have a middle b term, I can solve this using square roots. Let's square root both sides, and we get z equals. Now, one of the most important parts is when you're going to solve using square roots, you have to remember the plus or minus, or you're not going to get the 5 total roots like the degree says. And 21 can't simplify, so it looks like we've got our other 2 roots, plus or minus the square root of 21. In fact, I want you to understand that this is not a multiplicity. One of your solutions is negative square root of 21, and the other is positive square root of 21. And that counts for the other 2, which makes 5 total. In fact, on the answer key and the answered scrambled, I a lot of times listed out the separate solutions just to reinforce that you remember that that plus or minus means 2 separate things. All right, let's see, I decided to do number 4. So let's run through this. 18x cubed equals 50x, okay? Hopefully you were able to put this equation in standard form, very similar to the last one, and hopefully you were able to factor out a GCF. Now the GCF for 18 and 50 is only a 2x, okay? Which is going to result with a 9x squared, and 50 divided by 2 is going to result with a 25. Now this remaining factor right here, that is called the difference of 2 squares and can be factored more, okay? So we can split this into those plus or minus pairs. If we split the 9x squared 50-50, okay, it's going to result in 3x and 3x. And we can split the 25 50-50, and that's going to result in 5 and 5. And remember, the signs always go good times, bad times, plus minus. Okay, well, now we have this thing factored completely, so we can set each factor equal to 0. And I'm going to have you take it from there because I think that you can get the 3 different solutions, which again, there's only 3 total. Go ahead and solve for each x. This is not going to create a multiplicity because one of them you're minusing the 5 over and one of them you're adding the 5 over. So you're going to have plus or minus pairs, but it's not a repeating factor. Go ahead and solve for x, okay? And you're going to get your solutions. So don't forget, solve for x, get your solutions. Find them on the answer scrambled. All right, so the last one I decided to do was a trinomial. All right, so here is number 5. This is 40w squared minus 44 equals 0. Well, look at that. We're already in standard form. So what we're going to do is we're going to factor out a GCF. And the only number I see here is a 4. So let's factor out a 4. And the result is going to be w to the fourth power. 40 divided by 4 is 10w squared. 44 divided by 4 is 11. So now what do we do when the result is a trinomial? Okay, well, we look, again, you can always refer back to that factoring flowchart, but we can split the trinomials into two parentheses. We're going to split that first w to the fourth into w squared and w squared. Okay, then we're going to split the constant, the 11, and really the only options we have with 11 is going to be 11 and 1. And I think we can see that if the inner is 11w squared and the outer is 1w squared, if we make our signs plus 11 and take away 1, that's how we'll make a positive 10 in the middle. So we're going to go plus 11w squared and take away the 1w squared. Okay? So that's just that trinomial factoring. It's just a little guess and check. Now when I look at this, one of these factors can factor more. One of them is the difference of two squares. And what I notice here is this is the difference of two squares. So I'm going to leave the GCF. I'm going to leave the w squared plus 11, but this can split into the w plus 1 and w minus 1, right, using that Squaresville factoring. Now we're completely factored. And so now what I got to do is I got to set each factor equal to 0. Now when I set the GCF equal to 0, that's not going to yield a solution. The only things that are going to yield solutions are the factors that have a variable. So w squared plus 11 equals 0, w plus 1 equals 0, and w minus 1 equals 0. So let's go ahead and solve. I'm going to minus the 11 over, and we're going to use square roots because we don't have that middle b term. And so what we end up getting is w equals plus or minus the negative under the radical is indicated with an I, and we leave it as the square root of 11. Well, this is easy to solve because we just subtract the 1, and this is easy to solve because we just add the 1. So here's our solutions. Your solutions, there's 4 of them total. We have negative